let's get started. Today we're going to come back and talk a little bit more about testing and get some practice with similar types of questions that you might expect to see a week from today on the next quiz. Before we get there, I have a couple of things to review. First, we'll talk about a little bit of what you all did in the last task of professionalizing the developer environment, setting up some tools. I also want to briefly mention some expectations around, so we're about to release the quizzes after class today, and just talk briefly about that. And then we'll talk about patching beyond module boundaries. So there's a little bit more nuance than what we discussed when it comes to patching that you need to know in order to succeed in this next task. And generally about what's going on behind the scenes when you patch in Python. And then, again, we're going to get some more practice with testing in a worksheet today. So today we'll just be working with a paper worksheet that'll be handed out in just a moment. You don't need it quite yet. So I'll first mention the quiz. Results were great. I think the median was an 88 or so, which is a super healthy place to be. And I think the median on the multiple choice was around, I want to say 90% correct, which is awesome. I think it was actually north of that. And then when it came to the free response, which you'll get returned back to you after class today, primarily what we were looking for was some concrete responses and some technically precise language. And so this is one of the things that we're practicing in this course. So for example, there's a difference when you're interviewing or talking with a colleague about saying, you know, when you run git pull, it grabs the stuff and brings it in versus it fetches the remote branches and merges them in. Like there's meaningful nuance to the words fetch and merge in that example. And so we want quizzes when we're writing in English, and I would encourage practicing this on the open-ended responses for readings and homeworks and reflections on our tasks as well, to try and use technically precise language wherever the opportunity arises and to try and be a little bit more formal about the language as a means of practicing it and getting it correct. But very healthy quizzes by and large. If there were things that didn't go well on the multiple choice, we'll have copies of that in office hours. And just come by and we can go over those questions with you in office hours. And then for the free response, similarly, again, we are looking for precise language. So even if you said something that was close to, like that example before, the difference between git pull being, you know, it brings some stuff down and meshes it together. Even though that has the same kind of meaning or intent as it fetches the remotes and merges them in, there is a substantive difference between those two responses, and we really are looking for the more precise. Right? Awesome work on the last task of setting up tooling. And I've enjoyed going through the reflections on this and seeing what you all took away from it. One of the things that you will see when you get into industry is that generally junior engineers are not tasked with this. And historically, if you can imagine that bringing tools together like this, and for larger projects, they become even more complicated. There's a lot more configuration as well. Required a lot of background knowledge that you all were able to quickly come up to speed with. But so this can be really tedious when it's like you just want to do some work, but oh no, there's all this setup that you need to do to get a workbench going. And this is the type of thing that you just see in the difference between a vibe-coded hackathon weekend style project and true software engineering, is that intent and intentional decisions around which tools you're using, how the tooling fits in with your IDE for developers, how easy it is for developers to set up a coherent workspace on a new machine. Things like this are markers of a good software engineering practice, right? And so you all actually we haven't done this in the past, and this is one of the places where having some assistance with some of the configuration from AI, I thought, and it seems like this was true based on reflections, would help make this a feasible task for you all, to not tell you whether you should decide on black or rough, give you that option, and the important work was figuring out what they do and which one to choose. And as you hopefully learned, there's not necessarily a right or a wrong answer in these decisions, but you should be able to defend it based on the project that you're choosing. So with these tools, we saw increasing levels of sophistication in what it is that they were checking or doing. So the code formatter fundamentally was just trying to make formatting issues go away. How many of you are familiar with the term bike shedding? No one's heard the term bike shedding? So in computer science, this is one of those terms that you'll probably hear from old people like me as a way of saying we shouldn't be discussing or spending all of our energy on this unimportant thing. And historically, how code was formatted on a given team, like whether you put 2 new lines between function definitions or you aligned your keys and your values but with spaces between the values so that it looked like a table. Things like this, formatting concerns, used to be what we would call bike shedding concerns among programming teams. The term bike shedding comes from this idea that I believe it was originally termed in the military when they were trying to make big important decisions about national security. And somehow the committee, rather than focusing on the hard problem, focused on what color to paint a bike shed to store the team's bikes. Obviously not nearly as important as the fundamental problem of national security, but you might notice this phenomenon in committees or teamwork where you can get hung up on talking about something that's really not important to the problem that you're trying to solve. In the case of software, often it's, how do we use spaces or tabs? Do we, what's our code formatting? And so one of the big boons in the past decade that has helped avoid that bike shedding issue is that code formatters are almost ubiquitously used in most software engineering places today to just say, here's how we're formatting the code. Don't think about it. Don't waste your brain cells. Let's not waste our time arguing about it or thinking about this in code review. It's just going to be formatted one way. The Go programming language actually was responsible for making a big inroad on this. Linters are looking for problems that are not just formatting, but potentially like unused imports is an important one, and other code smells, you might call them, where there's nothing technically wrong with what you're doing. It works, but there's something that is a little dissatisfying about it. There's pieces of code that you don't actually need. Maybe there's some unreachable code. A linter would help you find that. You all looked at static type checking, setting up PyWrite or MyPy. This has become pretty standard in modern Python programming. And lastly, test harnesses, which PyUnit is an example, or PyTest is an example of. But the built-in Python has an older school style, JUnit style test harness that's built into the language called unit test. And there's a little bit more setup involved in that, but there's nothing technically wrong with it. It's just sort of gone out of fashion as time has passed. Any questions on things that you saw on TK04 before we get back into thinking about testing? All right. So we're going to hand out the worksheet. This will be coming around. And I want you all to go ahead and get started on the first page. While you're waiting for the paper, if you want to take a look at the slide, this is the setup for the first page. Don't worry about the second page yet. And I'll leave it to you all to read the code, read the questions, and try responding as a table. We will be handing these worksheets in for today's attendance check.
Yeah, actually, you need to make sure you don't.
One brief clarification I'll make on number 2. On the worksheet, I forgot to add a little bit more specificity. The main question we're looking for in number 2 is nice dates relative method. But if you want to think about the class in general, that's kind of an interesting question too.
Yeah, that's what I was thinking too. Is we got
So there's some trickiness on this one, but all that this was reasoning through. But if you'll notice on like after the if delta greater than 0 line, there's actually an if statement in there as well. And so and there's if that's a place where there are two branches on one line, you'd want to be careful about. But as you reason through it, you'll see that maybe in this particular example, there's other problems.
All right, let's have one more minute on this, and then we'll have some discussion. Actually, it sounds like we're coming mostly to a close. I want to skip to question number 2, and let's do a show of hands. How many of you had less than 5 as a response? How many of you had 7 as a response? All right, so we've got some 7s. How many of you had 5 as a response? We've got some 5s. Let's talk with someone who had 5, and then we'll come back to this. So someone who had 5 and can explain where your rationale came from. Oh, here we go.
I just thought that because there's 5 return statements, that means there's 5 outputted strings that could be covered. So that would mean that there's 5 branches that could be, covered.
Great. So one way of looking at this there's this many different return statements, and we can underline those. We've got one here, one here, one here, one here, and one here. That's 5 return statements. Does someone who responded with 7 want to mention or talk about where you got 7 from? Just coming in, watch your head. There we go.
So we said 7 because we saw the 5 return statements, but within each of the return statements, you can see it's either going to return like day with an S or day without an S, based on like another if statement in there. So there's like 7 different things that could be returned.
Great. So there's 7 different permutations when you look at it like that. Does anyone else who had 5 want to offer another reason for justifying 5 given both of the things that we've heard? All right, this is coming in real hot. Almost.
At least on that first, if delta is greater than 0, delta's never going to be 1 because it will return on the line above if it was.
Yeah, so that first 1 is a case that can never actually be hit based on what came above it. But what about the second one? Is it the same thing there?
No, it's not. So it might be 6, but.
I actually think it is the same, right? Because we're taking the absolute value of -1 right above it, which would turn it back to 1. And so there's actually 2 dead branches here, so 2 unreachable branches that would mean that truly there's only 5 reachable branches here, even if there are 7 defined branches. And you'd hope that something like a code linter would catch this type of off by 1, sort of off by 1 logic. This is really just a logical issue. So there's some trickiness here, and in general, it's pretty rare, although you would see it in C and Java style languages when you use the ternary statement with the question mark, value of true, colon, value of false syntax. The equivalent of that syntax in Python is, S if delta not equal to 1 is true, otherwise it's the empty string. So that is there are 2 branches there, and if our logic were better reasoned, we would have 7 unique branches that we could test. So, technically there's 5 reachable, 7 defined. So that's a shortcoming in our code, right? So in this, number 1 is actually kind of tricky, right? Because in this particular example, if you did reach every line here, you would have reached every possible branch that was reachable, but not everything that was defined. So I was looking for some fun debate and engaging some brain cells there. Any questions on the notion of reachable branches? Or just branching in general? Why do we care about this in the notion of testing? Well, typically you want tests that will cover all of your branches. And typically you don't want to write code that has unreachable branches. And if you're doing that, we could restructure this logic. Like it's actually a little extra for that if statement to be there. It doesn't make sense for that code to be there since it's unreachable code. All right, so let's talk about number 3. Identify one place in nice state where a method's behavior depends on something defined outside of the object and its inputs. So it's a non-deterministic or external dependency. Why that dependency cannot be controlled by just composing nice state with a different date time, and then how you would control it in a test in broad hand-wavy terms. Does anyone want to take a stab at responding to question 3? Let's try from middle to back of room. All right, we've got a brave soul here.
It said date time dot now because it depends on like the place and time you are when you call the function. And I said you could just patch it and set the value yourself.
Perfect, yeah. Before you hand it back, you said something interesting there. It depends on the current time and place. What does place have to do with it?
Because I think it's like a local time, so you could be in Australia, it'd be the next day. Or just, it could be here and it's today.
Yeah, so time zone has a big impact on date time functionality. And one of the real complications in working with date time in just about every programming language is knowing whether you're working with a date time that's in the system's time zone or Greenwich Mean Time, which is the offset of plus 000 for hours shifted from that time where the start of our day is located. And we don't really have to worry about those things here, but you're exactly right in identifying, and let me highlight this on the slide, where a source of non-determinism in our program is coming from. And here, I mean, it's deterministic in the sense that we know that this is going to go ask our system what time is it, and we'll get reported back as a new date time object whose values are filled in with the current date time of the system that this code is running on. But we mean this in the sense of if you were to run the same program twice and you get different results, which you would if you ran it sometime in the future, this is a place where you get a varying response back. Sources of non-determinism or external dependencies like this, or what we've learned, are places if you want to write tests that test this logic, we need a way of controlling that non-determinism and making it deterministic so that when our tests run, we can know predictably what it is. So we're going to look at patching this. And that's actually going to be the focus of the next page. And I want you all to go ahead and try working on this as a group, and we'll spend a few minutes on this, and then come back and discuss it. 1 more minute on the first question, and then we'll have more time for the second question. 1 more minute on the first question. Thirty more seconds on question 1. All right. Let's have a review because this was kind of covered quickly at the end of the last lecture, and we've had snow in between, so it's been a minute since we've talked about fixtures. But let's talk about how fixtures come to play here. This first question asks when test short format is run. That's this test defined here. Oops, let me move over to my iPad. That's the function defined at the bottom of this test module. What is its printed output? So if we look at this test module, we're seeing 2 fixtures being defined. One's named fixed now, and it's giving us effectively a timestamp that is rooted, it's like hard-coded to be February 4th, 2026, today, right? And all that fixture does is it always returns a date time that is right now. There's another fixture called mock now that actually takes as an input this previous fixture. So this is one of the cool things about fixtures. Oh no, my pen died. Any chance I can borrow your? I think I need to get a new pencil. It has trouble charging.
You have to like snap it on the.
Okay, yeah. There we go. Hundo. All right. So fixtures are composable, which is very cool. And remember, the big idea about a fixture, actually, before I even talk about mock now, I'll come back to that. Let's talk about the test that we're focused on. Notice that the test that we're focused on has this parameter named fixed now. And our test harness, PyTest, is responsible for running this test function. So it's responsible for providing this parameter. And it uses this really cool convention for parameters, right? It looks at fixtures that have been defined and registered, so this one has, that have the same name as the parameter, right? And so this feels weird at first, but it actually winds up being a really nice developer ergonomic when writing tests that allow us to inject this particular logic, or like PyTest will ultimately call this function, take its return value, and then pass that as the argument to this test. So when PyTest goes to run this test, the first thing it has to do in order to be able to even enter this particular function is go set up this fixture. And it's going to do this, and we will see fixed now gets printed as the first line. And then a new datetime object would be constructed, returned back to PyTest, and then PyTest would take that and pass that as an argument to our test function called test short format. So fixed now would be bound to an object whose values were set up and constructed there. And the first thing that happens when we enter this is we would see test short format printed. Right? And then what we're doing is we're constructing a new nice date object with this date time that was set to be today. And on the definition of this, you'll notice that there's a method named short format that returns a string format of time. And that has some special, we could briefly look at it. So what we were calling was this particular method. And with the date time that we constructed, that was our date time that was today, we use this little pattern language that you can look up the different substitutions available to you, but this is the 4-year representation of the year. Lowercase y would have been the 2-digit representation of the year, so 26 instead of 2026, and then month and day, right? And we would assert that after calling that method, we get this result, right? And so notice this is kind of neat. We were able to, on that method, short format, without doing any patching, substitute in a datetime object and get predictable results in doing so. So in this case, what the fixture provided was effectively a helper function to work up the arrange steps of a test. And we didn't format this test in this way for slide purposes, but the arrange steps were effectively handled by the fixture, and that's a pretty common pattern. All right, so the second part of this question has to do with testing the relative method. And it's going to make use of this mock in an interesting way. So I want to briefly mention this mock. So notice this mock is another fixture that your test for relative will use. And what's cool, another cool feature of fixtures is they can compose with one another. And PyTest is clever about figuring out this dependency graph. Behind the scenes, it's effectively making a directed acyclic graph, like you might remember from 210, goes all the way back to the root dependencies, starts spinning those up, calling those functions. But when it sees that mock now needs fixed now, before it even tries to execute this function, it's going to go call that fixture first. And then mock now would get called and produce a magic mock. And you'll notice that what we're doing is we're mocking the now function's return value, or the now method's return value, to return fixed now, or the current date. All right? So with that, I want you to take a stab at writing a test that's separate from this one. It will make use of mock now. It will probably also make use of fixed now. And see if you can patch the functionality from the implementation on page 1 in order to have a predictable and correct test for one of the branches in that method. You don't have to test all 5 or 7 branches, just one branch. Try spending just a few minutes on this, and then we'll come back and talk about it. 2 more minutes on this, 2 more minutes. All right. It's okay if you didn't get through this. This was meant to be a pretty challenging question to try and motivate thinking about patching and also thinking about mocking and fixtures. So I'm going to switch to my iPad and show you what a reasonable, if you wanted to test for the today branch, which is just one of the branches you would want to test from, what its function header might look like, all right? So let's say we wanted a function that made use of both of those fixtures, because ultimately we want to know what is the date time that we're fixing our test at, which was hard-coded to be today's date, but that would still be true tomorrow or in the future. And we know that when we ultimately go and patch in some behavior for the datetime.now functionality, we want that to be a mock that we can control, and so that the .now method call winds up giving us back a specific point in time. And based on that mock now, it would also be the fixed now. So they would be one and the same, and you would expect that if what the mock returns is the same as fixed now, when we go to call the relative method, that we would get back today as the string, because that's the branch we would wind up hitting, right? There's a really great question that came up offline about when these fixtures would be called. So I don't think I can fit them all on here. But in the first example, before we started writing this particular test, if we were just thinking about the starter code you were given, the mock now fixture would never be run. So these fixtures are run on demand as your tests need them, and they get rerun per test unless you make some special effort to say, don't rerun this, just reuse it, like a cached value of it across a module or something like that. But for generally, the default is the mocks always, or sorry, the fixtures always get rerun just before the test that needs them as setup, right? So now this mock, when PyTest goes to run our test relative to today, this would get evaluated, and mock now would run, and both of those fixtures would be called to set this function call up. Now I've got some implementation here. Let me move it up. And there's something that's going to be a little bit surprising about this that we're going to discuss that I wouldn't have expected you to get right. But what we're going to do is we're going to patch the date-time class in the nice date module of the services package. Now this is a detail that I want to come back and talk about more explicitly. I would not have expected you to know that. That's a surprise, and I wanted it to be a surprise because the inclination is to always just patch datetime.datetime or just patch datetime. But we have to patch names where they're read and not relative to our current testing module as soon as we separate these two out. What are we going to patch that datetime object with? We're going to patch it with mock now. And then the test is pretty straightforward from there. We set up a new nice date instance. We give it fixed new as the date that we're anchoring on. And then when we call the relative method, we expect today to be what gets returned. All right? So let's break down what's going on with this fully qualified name, services.nicedate.datetime. The idea of a fully qualified name is more pervasive than just Python. You've seen it in Java as well, where you know when you import things into a Java class, you can use those imports by a shorthand name, but you can also reference things throughout Java's namespaces using their fully qualified names. Fully qualified names are an idea in many different places, but that's where the services.nicedate.datetime comes from. And that's the fully qualified name of the datetime object that we imported into that module on page 1, right? So briefly, just to remind us how we got here, on page 1, we have this class nice-date. It imported datetime from datetime. And this is a funny line, but just to explain something, this is a module, and it exports a class that has the same name. Why it uses lowercase letters for the class name is sort of an antiquity of the Python programming language. It's been there like this for a long time, but that is actually a class, datetime. And then in our test, and notice that this was defined, on the worksheet, it shows you this was defined in services/nicedate.py. That's what gives us the package services and nicedate as the module. And then in the test, we are also importing nicedate in this way, and this was defined in tests/services/test nicedate. And so what we're about to look at is when we patch beyond a module boundary, we have to be careful. And the reason why we have to be careful has to do with how Python performs its name resolution algorithm. How do we know what name we're talking about when a function or a method gets called or a variable gets referenced? And we want to make sure that when we patch something in, we're actually patching the behavior in the module we're testing, not somewhere else, right? So I've got a slide that I'm going to talk through with some notation. And in this first file, we've got our test. In the second file, we've got our class that implements this. And then over here on the right, we've got a very hand-wavy representation of what's going to be going on in memory, right? So when PyTest first evaluates our module, our testing module, what it's going to do is it's going to create a new entry in its sys.modules dictionary. So notice this key is actually the fully qualified name of our testing module, right? And you can import this, and you can look at this. This is something that if you open up the REPL, you could play around with this directly. But what happens is that key gets bound to a new object that's of type module, and everything that we import or define at the global level winds up becoming an attribute of that object, right? So here, because we imported nicedate, nicedate in our test module is a top-level attribute of this module object. Similarly, when we defined, this should have had a def in front of it, but when we defined test relative, this is also going to be this is a function definition. And if we were to look at what are these bound to, this would be bound to a class definition, this would be bound to a function definition, and so on. Now, something interesting happens when we imported this file, right? Python had to actually pause at that point and go load the nicedate module. And in doing so, it added another entry to sys.modules, right? So this is the second entry here. And it's going to bound that to another module object. And its attributes are going to be the global names in that file, right? So date time was imported, and that's a reference to the datetime object, which we'll see. Although at this point in time, we would have needed to go and load the date time module into the system, and that's where ultimately this module has a member, date time, bound to the class definition, right? So notice that in the path towards actually overriding what it means when we call a method on our date time object that's in the services.nice state, we're going to have to be very careful because it's not necessarily, if we overwrite this and bind it to something new, we want to be sure we're targeting that particular connection and not the one that's in the date time module, right? So when we got to the point of calling in our example, datetime.now, this is what we're patching over. What we've done in the example solution is we're actually saying this date time is going to be our mock, right? And by targeting that specific date time in this particular package and Python module, we're able to override just this object in that module. If instead we had overridden datetime.datetime, or sorry, I should just point this to somewhere else. Like if we had rebound datetime.datetime to a mock, that would have been that could work, but it wouldn't work for our test because our test is actually still calling nice date. Nice date has its own binding of date time to the original class that wouldn't have been reset or swapped out and patched. Right? So this is something you want to be careful with. And the rule of thumb is you always just want to root your replacement for patching in the imported module's namespace. So find the package name of the module you're trying to patch into and what it imports at the very top, and that's the name that you're targeting with a fully qualified name. All right. I had a slide in here on, I'll post these slides after class. There are cool things that you can do with fixtures in parameterizing tests. So you could have one test that actually tested all the different branches that are reachable. We might come back to that on Friday. And otherwise, your current homework is writing the unit and integration tests for task 5. And we'll have some more readings on HTTP and API as we start looking a little bit further up the stack towards a back end. I'll see you all on Friday. And hand in your worksheets to a TA or myself at the front, but be sure someone affiliated with the class has your worksheet. Great work. Yeah, these are handed in at the front or to a TA.